brief introduction. I might just read his bio here a little bit. So Paul is from Great Neck, New York. He graduated from Jacksonville University in 1970 with a BS in chemistry. After graduation, he taught high school chemistry and physics. After moving to Boulder, Colorado, Paul worked as an analytical chemist in bulk chemical manufacturing at what was then Syntex Pharmaceuticals. From the mid-'80s, he worked in the financial services industry, starting at Merrill Lynch. After coming to faith in 2001, Paul discovered the world of Christian scholarship, and this replaced his former passion for cross-country ski racing and trail running. Paul formed classes at his local church to communicate and popularize this material. As a curriculum, he self-published his own book, You Bet Your Life, a toolbox for making life's ultimate decision. It is a philosophical, scientific, and historical defense of the faith, urging the reader not to be reckless with their souls. Paul still gives occasional talks at both CU and a former apologetic series. And he's also a volunteer independent research associate. He's a volunteer independent research associate. So thank you for coming, Paul. We appreciate it.
Thank you, Trent.
And guys, when you're thinking of questions, so we might not have some of your friends here that you might want to hear this message, but if maybe you guys have any spiritual conversations with your friends in the past and some difficult questions have come up, we have both Paul and Jim here who are both very well versed in some of where science and faith contradict or philosophical questions. So get ready. We're gonna have some Q&A at the end. So be thinking of tough questions you have.
Okay. Let's see. I don't want to be staring right into the spotlight there. I think I need a middle position. I want to thank Trent for asking me. I'm an old retired guy, and I love to be able to do Christian service because otherwise I start trying this stuff out on my wife, and she gets annoyed and she says, "You need students." And so I thank you for this opportunity. Just this past August, in furtherance of my hobby interest in science and faith, the Discovery Institute, which is a think tank for intelligent design, held a conference. And it wasn't exactly titled this, but its purpose was to kick off a book by one of their key scholars called Undeniable. And what's undeniable is that life is designed. And so I thought it would be a fun conference to go to and a neat road trip to take with my wife. So we drove 3,000 miles and had 3 good days with some really wonderful people. So I had all these ideas in my head about biology as engineering. And I get home, you check your messages, your message machine's all backed up. And Trent's there, and he said, "Can you do something for me in mines?" Well, what a coincidence. I just come back from a conference, so I'm kind of loaded with this stuff. But I want to make clear that I'm not an expert. I don't have a degree in any of the specifics of this. This is a hobby interest for me, and I try to keep up with at least the popular literature and sometimes a little bit more of the technical stuff. But I see myself as kind of a step-down transformer from taking the arguments that scholars make and trying to make them available to the general public. And I'm really excited to have a science literate audience here tonight. So if I talk about tenular power, I don't have to describe what that means. So my talk is designed to be...
Thank you.
My talk is designed to be read, so I stay on track, and I have some other sections where I go off script a little bit. But then I've got plenty of time for question and answer, and then I have some of the typical objections that are raised against this. I understand Bill Nye, the science guy, is up here, so I'm sure he'd have some objections. This may or may not be the kind of things that he would raise. So my talk is titled, Biology is Engineering. So I hope to give you the sense that biology shares more than just appearances with engineering. And I hope to show that this is not just a metaphor or a weak analogy. Like our introductory hymn tonight was giving glory to God through the creation. Well, that's sort of a nice sentiment in the form of a hymn, but it really is true. Just as you wouldn't confuse an engineered system with the product of natural causes or chance, or any combination of the two, we should be just as suspicious of those explanations when they're applied to living systems. The central problem of biology is the origin of functional information. I know we have an information theory guy here tonight, so I need to be on my toes. I'm going to loosely define functional information as a set of symbols that make up instructions on how to perform a biologically useful function, at least in the context of living things. You probably remember from high school, the basic paradigm of modern biology is that DNA gets translated into RNA, which is then fed into a transcription machine, which then pumps out a string of amino acids that fold up into proteins and do the work. So it doesn't matter whether you start with DNA or RNA, which have 4-letter character sets, or you start with proteins with 22 letters, because there are 22 amino acids found in life. Original life researchers debate the starting point. Some people say, no, proteins are where the action is. If you want to metabolically do anything, you have to start with proteins. And others say, no, you need an information storage and replicator system first. You have to start with DNA or RNA. So that problem is still debated in origin of life circles. But proteins, the action molecules of life, whatever you use as your starting point, they're going to have, if they're going to have biological function, they have to be in the right sequence. It's a deep mystery how natural processes can hit the right sequence, since there is no preference in the chemistry or physics in the order of the molecules that make up the strands. Jim, you want to go to our first slide? But sequence is everything in biological activity. Time and chance can be shown to be inadequate. Something is missing, something beyond chemistry and physics. So now I want to talk about the sequencing problem. And I'll take your pointer from me. The typical protein might have 150 amino acids in it. You can think of them as letters along a string. So, how many letters? Let's say we have 150 letters along this string. They're amino acids, and they're organic molecules. And they've got a backbone, and they've got things sticking out the sides, and some are hydrocarbon groups, and some are charged groups. Some are positive, some are negative, some are acidic, some are basic. And how you have those along that string affects how it will eventually fold up. So the sequence along this string determines the fold that you finally get, and the fold determines its biological activity. So we've got a class of molecules that we can generally call biopolymers. They're chains made up of other things. So how do we explain the sequencing in biopolymers if it's not like chemistry and physics? Remember, there's no preference as to which way these things bond to each other. They can be in any order. There's no chemical or physical reason for them to be in the order that they're in. So the problem is kind of like a bike thief with a lock. So biology, in order to hit on a function, has to search a space of combinations to come up with something that works. So let's say you've got a bike lock with 4 dials on it, 10-digit dials. So you've got, How many combinations? 10,000 combinations. So if you're a bike thief trying to get a bike out in the time that the movie's on at the theater, you've got a fairly difficult problem. Not impossible, but difficult. Okay? Original life theorists like to, right now the popular idea is that RNA was the starting point because they found that RNA can be self-catalytic. It can cut and snip itself and do other things. So it looks like maybe we could get some activity out of it. But the minimum size for catalytic RNA is 200 strands or base pairs. RNA has a 4-letter alphabet like DNA, and one of them is different from your cell. But these, so you have 4 letters, a string of 200 of them, and if my math is right, this is the equivalent of a bike lock with 129 10-digit dials. This is beyond the probabilistic resources of the universe, a universe that just has 10 to the 80th particles in it. That would be protons, neutrons, electrons. And if you want to run out the math further, there's something called Planck time. It's the smallest quantum of time. It's like 10 to the minus 45th seconds or something like that. And so if you had each particle in the universe making a decision about which order these things could be in, with the whole universe computed for 14 billion years, you're not going to get to the solution to some of these sequence problems. They're that intractable. So we now have not only the problem of getting life started, but evolving life. Jim, next slide. Oh, I'm a little ahead of myself. As we talked about, the 4 letters of DNA or an RNA, pick your choice, actually map through something called codons. It takes 3 DNA letters to map, or RNA letters, to map to a specific amino acid. What this does is it translates the 4-letter RNA language into the 22-letter amino acid language. So that mapping takes place. That's what's referred to as the genetic code. And the protein product is based on the amino acids. And each of the 22 amino acids have shape and charge differences that causes the strings to fold in a limited number of shapes. I'm probably one ahead of myself, but on the previous slide gives you an idea of one of those shapes. This folding preference is independent of the fact that there's no bonding preference to the amino acids, but it's highly dependent on their sequence and the way their charges, sort of how their knees and elbows stick out. The experiments have been done so that it's estimated that if you try to put together a functional fold to make a protein, you have to search 10 to the 77th number of different protein folds before you hit on one with a sequence that's going to have biological activity. That's close to the number of particles in the universe. So that's the search problem involved in coming up with finding a functional fold with biologic activity. Now, I don't want to give the impression that the whole strand has to be completely exact. There's an internal structure to some of these things. Next slide.
Beyond this one too?
Nope, back to the other one.
Is that the one you want?
Yeah. So the action happens sort of outside of these helices where the charges are exposed to the environment. And internally, the sequence isn't quite as important. So you tend to have, the cell is an aqueous environment. You tend to have the charged areas on the outside and the non-charged or hydrophobic parts on the inside. And the sequence isn't quite as critical there, but still, this whole construct to have activity is still highly sequence specific or dependent. Okay. One of the researchers at this conference this past summer, his name is Doug Axe, and he wanted to know if you could evolve two of the closest enzymes that he could find. And enzymes are collections of protein that act to catalyze chemical reactions. So he wanted to see if he could, get back on script. Enzymes are clusters of several proteins that do the cell's work. They fit hand in glove onto a substrate and cause chemical reactions that otherwise wouldn't take place. Engineer turned protein chemist Doug Axe wanted to know if the mathematical improbabilities based on string length or bike locks would be found in actual experiments. To test these ideas, he picked enzymes A and B that are strikingly similar in their appearance and yet functionally distinct. I think you can all agree that they're similar in their appearance, but yet they have greatly different functions. So the goal of his experiments would be to see if he could test the mutations and turn one into the other. So he had a lab team, and they selectively did various mutations on these. And the idea was to come up, if it were feasible, to turn one into the other, given the reasonable time frames, reasonable being the age of the Earth. They can, now, he was using a team of designers to do this, and so they would actually go in where they thought they could intervene and see if it would work. And from extrapolating from that work, they could tell that, well, if we had to give it this much help to get a change here, here, and here, how much more work would have to be done by chance. So the team concluded that it wasn't feasible over geologic timeframes to change A into B. Now, his work was published in a peer-reviewed journal, the Journal of Molecular Biology, 2004. So if this was accepted in a scientific journal, that evolution can happen, or can't happen, can't we all just go home and declare that evolution is dead, or at least Darwinism? Well, somebody did go home. It was Douglas Axe. The reason he went home is he broke the orthodoxy of the tribe. And by this I mean, Doug Axe's background should be interesting. He was an engineer at Caltech. He was a Christian. He always wondered about these issues, evolution, Darwinism, and it was something that struck him about living systems is that they couldn't take place by accident. Well, was there really any empirical evidence for that? So he switched from engineering to protein chemistry, and he was doing a postdoc fellowship at the protein lab at Cambridge University, where Watson and Crick did their famous work on DNA. And so when you're a postdoc, you need permission from the lab director. I think I have a worthwhile project. Can I put together a team? Can I get resources? So they said, yeah, this looks like an interesting thing to attempt to do, so go ahead and do it. Well, the lab director, upon looking at emails that weren't supposed to be seen, familiar ground, he said, you've been corresponding with the Discovery Institute, which is the intelligent design think tank. So your work is under suspicion. The next thing that happened is the newspaper, I believe it was the Manchester Guardian, got wind of this, is we have a creationist in one of our venerable institutions doing a nefarious project. So that in turn made its way to the House of Commons. There was a brouhaha in the House of Commons, and Tony Blair ultimately got involved in this thing. So I think that's quite a story. And it's like, don't try this until you have tenure. But the point is, if evolution, or more specifically Darwinism, can't turn two things that are this closely related, one thing into the other, how is it going to do with the big stuff, like turning sponges into orcas. I had a better arm. So, but nothing ever happens easily. There's always an objection. Next slide. When you do this type of work, you have to let the process criticize it. That's the way science works. So what is the other side? The objectors say that there's actually no need for protein evolution or the evolution of genes that code them. You just need to let the environment turn on different genes already present. If this is true, this would soften or eliminate the sequence problem. Now, as many of you are aware, maybe not, in DNA, there are what's known as coding regions and non-coding regions. The coding regions are the codes that make the proteins, the enzymes we just looked at. The non-coding regions were for years thought to be junk DNA. How many have heard that term? Okay, most of you. Well, work over the last decade or so has shown that junk DNA is not DNA. It has function. And this has been a great disappointment to the evolutionary establishment. And so, but now, trying to make lemonade out of lemons, what the evolutionists are saying is that proteins evolved into a final form early. And the way you get further evolution is that you make changes to so-called genetic circuits. The proteins are already there, or at least the code for them, but you turn on the coding regions by interacting with the non-coding regions. Let me see if I can say that a little better. So you just need to let the environment turn on different genes that are already present. Well, how will the environment do this? Well, you have a hormonal environment in your body. If it's subject to stress, or more oxygen or less oxygen, it causes molecules to come in and dock with different regions and turn genes on and off, causing proteins to come into function or to turn them off. And these gene circuits are sort of logic gates that illustrate how genes are turned on and off. And by switching on certain genes, you make new proteins, and this is how you evolve new species. They respond to the environment, environmental signals come in, they hit these gene regulatory networks, they turn on different parts of them, and different proteins are made as needed. So you don't really need to evolve new proteins, you just need to turn on the codes that are already there. Now, one thing about these gene circuits is that they appear in early stage embryos. And when you try to make changes to them, you always crash the embryo and it dies. So in other words, these circuits are not mutable. Now the evolutionist rebuttal is that they're called DRGNs, developmental regulatory gene networks, that they were mutable in the distant past, but they're not mutable today. Now I find this is a really interesting way to put it, because it not only begs the question of where these gene circuits came from in the first place, but it's also a type of argument called special pleading, where you ask for an objection that somehow the science was different from the past. You know, 3 billion years ago, nature could monkey with these things, but we can't today. I thought I'd mention that if you look into a microscope, you're not going to see one of these, okay? But there's nothing like a circuit board in the cell. But these pathways are real, and they should evoke a sense of design. And next slide, please. Next slide. Okay, because what they amount to is logic gates. Here's an example of where a signal comes in, signal A, there's an activating promoter, it turns on a gene, it makes a gene product, the protein, it's gene 1, and then that can land on another promoting site, and then make another protein, so you have these interacting systems that turn each other on and off. They're truly logic gates. And so, I mean, this just reeks of design, and the fact that you've got these really complicated pathways. You want to back up one slide? I mean, they're this big and they're bigger. And it's really difficult to see how anything like this can evolve, especially when experimentally, if you make a change to it, you crash the whole thing and it dies. Okay. Now I want to move up from the protein level to the systems level. Here's where we're getting into engineering. The sequence problem by itself poses an insurmountable barrier to just getting one functional protein. But a suite of functional proteins are needed to build just the first layer of a biological system. Jim, if you go to that last slide. And this is what I mean by a system. This is true in, I believe, in engineering as well as life. You've got these basic elements, subcomponents, main components, and a functional whole. So the problem, we already see a sequence problem in writing a word, but then beyond that we need another layer, sentences, and another layer, paragraphs, and then perhaps subchapters and chapters before we can make a book which would correspond to a functional whole. So we've got all these different layerings. So to have a functional organism, something might be called alive, purposeful, and reproducing. We need integrated sense of proteins that know or can anticipate in advance how all the parts will relate to the whole. This involves foresight, and this is a whole level of organization beyond just sequencing. And we already noted that sequencing itself is an intractable problem. Okay. Next I want to talk about busy holes. Busy holes in whole projects. A whole is something that is complete in itself. A carbon atom is a whole. You can't break it up and still have a carbon atom. Piles of sand are not. You can split them up and you still have piles of sand. A busy whole is an active collection of things that causes us to perceive intent because it accomplishes a big result by bringing together many small things in just the right way to form a whole project. It sounds like an engineering concept, right? Putting together a whole project. Next slide. Go backwards. That's it.
Oh, which one? This one?
The guy in the submarine. All right. I think he looks like Jim, by the way. Okay, this is a device called Tavros 2, and I've labeled it high-tech pond scum. And this is operated by the University of South Florida to measure and map the length of the Gulf of Mexico. Length and depth and pressure and all of those things. It dives at night and it surfaces by day to recharge. Those are solar panels on the back. So it has light gathering, energy converting and storage, sensors, propulsion, all integrated for functional coherence by software. It's clearly designed. Okay, next slide. Now we're into higher tech pond scum. This is a cyanobacteria. This single-cell organism can form filaments and mats. We've all seen them. It can do more than just surface to collect sunlight. It can control its depth and orientation to collect the right part of the spectrum. It makes all of its own components. It has a membrane and antenna system to catch photons. something called a photosystem to convert light through an electron transport change to an unburner chamber. The unburner chamber is that thing called the carboxysome. There you go. Thanks. And what I mean by an unburner chamber is photosynthesis is the opposite of burning. What photosynthesis does is it takes carbon dioxide in the presence of sunlight, and the long story, the end product is a sugar. So it causes an electron flow into the carboxysome that does this unburning to convert CO2 to sugar and run all the other machinery, including a propulsion system. These things actually have little flagellas on them that can move the individual in the colony. And of course it has a DNA room in the center that has the information system. Now, the next slide. This is a detail of the photosystem, of the electron and the electron transport system. So this is a complex of proteins that have joined together spatially to fit just the right way. It consists of 12 different proteins, a lipid complex, and 4 large organic molecules, 417 pieces in all. The system is what's known as irreducibly complex, meaning that all the matched parts have to be present to work. So that should raise the question is how do you evolve them all independently so they arrive at the right place together? And furthermore, you need a program to put them together in the right sequence. So on my bacteria, this is just a snapshot, and I don't really pretend to understand it. But I'm convinced that things like this just don't happen unless somebody can show a plausible stepwise path, something that Darwinian gradualism lacks. You know, there's nothing in the literature that tells you how a gradual mechanism can build one system or another, you know, to get these things. Ultimately, all molecular assembly lines inside the cyanobacteria and their associated gene and regulatory circuits do what they do in order for cyanobacteria to take their place among spectacular living inventions that surround us. It's also worth mentioning the cyanobacteria appeared about 3.5 billion years ago. Geologically, this is just after the Earth is deemed to have cooled off from an event called the Late Heavy Meteor Bombardment. So this appears just after the Earth cools. This is contrary to Darwinian gradualism. We are left to think that poor Cavros 2, our ocean mapping submarine, is really no more worthy of comparison to the lowly cyanobacteria than it is to the exalted dolphin. I hope the conclusion you draw is that intentional busy holes are always designed by an agent. So that can be an engineer or it can be the engineer. This has huge implications for any purely naturalistic account of life. It fits comfortably into a theistic worldview. And these problems have some notable non-theists in both science and philosophy now scrambling for an alternative paradigm. Despite the discussion, and it's probably going on in the next room, within the naturalistic Darwinian community, these problems are known. They're not just something that a creationist or design theory has come up with, and they're deeply disturbing to that paradigm. It's much more comfortable in a world in which there's a designer. That we see this type of design in nature that we find in our own inventions should not surprise us if we are made in the designer's image. So I have some more material to do in the way of comments and application after a Bible study or a sermon that has an application. So I'd like to do that. But let's break at this point just to go back and see what the questions you might have about things so far. So does it give you an impression of design when you see things like circuit boards? And, do you have an appreciation for the sequencing problem? Any questions on those lines?
So the sequencing problem in particular kind of fascinates me. There's a lot of current research actually in the electrical engineering field of this problem in terms of genomic signal processing, because you can look at the different four nucleotides and you cut acids down and basically use the same math you would on radio waves to build up a transform. And they're looking at basically all of this non-coding, this junk DNA, and saying there has to be some way to figure that out. It's a new technique, kind of. It's come up over the past 10 years. I was wondering if you heard anything like related to genomic signal.
Well, I mean, the research paper that this is based on was 2004, but, you know, in terms of the information problem, I want to contrast information with order. I know this is not exactly answering the question, and I think the answer is no, off the top of my head, because I'm fairly current with what comes along within a few years, because I follow the argument on the internet. What can I say? But I really don't think there is any work on that. But one of the areas in original life research is the concept of self-ordering systems. An example of that would be a tornado that gets organized, or a hurricane, or a snowflake. And so some people think that these systems come together because there's something inherently self-ordering about them. But order is a low information idea. For example, if I think about a salt crystal, where I've got sodium chloride, sodium chloride, sodium chloride. It's like if I write an instruction set for that, it's put in an Na, next to a Cl, then, you know, repeat the sequence. There's very little information in that kind of thing. And so when you're looking at self-ordering as a way of creating instruction sets and alphabets and text on a page, that you just don't see self-ordering systems producing a lot of information that conforms to something that does something. The problem is a little like driving down the road with a truckload of scrambled letters and having dumped out the back and expecting to come up with War and Peace in the letter sequence. You know, that's the kind of problem you're dealing with. Now, is there a degree of self-evolution possible within things? Clearly, yes. Adaptability is built into living things. And it's a very rough analogy, but it's kind of like having a word processor. You know, you've got the story of the three little pigs, and we know they're pigs, and huffing and bluffing, and straw houses. So you've got that on a word processor in different paragraphs, and you can move blocks around and maybe get the order of the story differently. And so there seems to be some, you know, cutting and splicing chromosomes and moving chunks over, you know, and getting different things that come up. But it's pretty much all in a rearrangement of the actual information content that was already there. So we see rearrangements, but we don't really see significant amounts of new code being written that actually does something. Does that help a little bit? Yes.
I've heard lots of really interesting arguments, especially this one about intelligent design in biology, but does intelligent design ever look into other fields for evidence?
Yeah, in fact, if I hadn't been to this conference this summer, and Trevor just said, come on down here and speak, I would probably have started at the beginning and looked at intelligent design in the world of physics or in cosmology. And that's a logical starting point. For this stuff to happen, you have to have a life-permitting universe. And a life-permitting universe has to have carbon. And carbon's the way it is because of the rules of quantum mechanics. the reason it has a tetrahedral structure. Without that tetrahedral structure, none of this complexity would be possible. And that has its origin in quantum mechanics. And, you know, that's you've basically got just 4 quantum numbers, but why that works the way it is, that has to be built in from the beginning. And then there are a lot of other parameters. To get a functional universe off the ground, sometimes I probably have a quarter in my pocket, but it's really a dime. I've used this illustration with groups before, that at the instant of creation, if the mass of the universe had been different by the amount of 1 dime, we wouldn't be here having this conversation. That's how balanced on a razor's edge the conditions for a life-permitting universe is. Because if we're any less massive, everything would have just diffused off into basic particles. If we're any more massive, things would have collapsed into neutron stars or maybe even black holes. All the physical constants, the speed of light, Planck's constant, fine structure constant for electromagnetism, all of these things have to be what they are, and some of them could be maybe with 1%, but some of them have to be 1 part in 10 to the 160s, and there's actually a number out there that's poorly understood. It's something called phase space, which some of you may understand better than I do, and it has to do with the amount of entropy in the initial state of the universe, and the math theoretician Roger Penrose, Cambridge, said that the creator, and he's not a theist, but he said the creator had to hit the right phase space to 10 to the 10th to the 123rd. In other words, you've got to stack it as an exponent. You can't write it out. There's not in space enough in the universe. Space enough in the universe to actually write out the zeros. So those problems are really intractable, and they obviously come first before you can even talk about any of this. And it's only because I've just been to a conference about this, you're getting this instead of that. So if you ever want me back to do that one, that'd be a neat thing to do. Was that your question?
Yes, thank you.
Okay. All right, I'd like to give you a few more things to think about on the way out. I may have let the cat out of the bag, but one term I've tried not to use too much during this talk is intelligent design. And the reason is, it's just a loaded term. I mean, you bring up all sorts of rancor. One of the workers in the intelligent design movement is Michael Behe. He spoke here last winter or winter before that. And he came up with this idea of irreducible complexity. And Mike Behe is fond of saying, because everybody is saying that irreducible complexity has been refuted, well, not in any scientific journal. And he said, if you want to find arguments about this on the internet, he said, just type in my name and your favorite swear word. You'll come to everything there is about irreducible complexity. It's that low to the topic. So what I presented here tonight is one part of the ID position, and that is the work of an agent is empirically detectable. Now notice I haven't named the agent. And part of this is ID wants to promote itself as a scientific theory. And that's one reason it's so offensive to scientists. Because a lot of them say, well, this is nothing more than creationism dressed up in a cheap tuxedo. In other words, you religious guys are trying to get in here and do the science thing and look legitimate. But the experiments to evolve enzyme A to enzyme B were certainly scientific. And they demonstrated something empirical, even if it was just a negative result. So if these arguments are sound, I don't think we're out of order to see the work of a designer in the creative order. In fact, the very first hymn we sang was about that. You know, about what was that hymn titled?
All creatures of God.
Yeah, and you know the creation praises him. Romans 1:20. So I don't think we were, even though this is a scientific argument and I can present it itself, you know, I want to be sensitive to to the venue, but as Christians, I don't think we need to be shy about it. The Discovery Institute is intentionally non-religious. They've got Christians, Jews, even agnostics working there. Basically, anybody who is dissatisfied with naturalism or materialism as a complete account of reality is welcome to work with them. Now, the next thing I'd like to bring up, because you're really likely to encounter, especially if you're in a Christian academic institution, or even a lot of churches these days, is called theistic evolution. Show of hands, how many have heard that term? Okay. I think you need to be familiar with it, because despite its name, it does not mean that God is guiding evolution. If that were the case, it wouldn't be a problem. Rather, as used by most of its proponents, it's just an overlay of theism on what would otherwise be a fully materialistic and usually Darwinian account. And so what they like to say is that God ordained the Darwinian mechanism as his means for bringing forth his creation. Well, let's think about this. God operates with a purpose. And if the Darwinian mechanism is inherently purposeless, then I suggest that not even a purposeful God, even if he's all-powerful, can use a purposeless mechanism to achieve a purpose. I think you're into a contradiction there. And I tell people that I got into a big argument at my former church over this, and they were trying to baptize the Darwinian process and say, no, it is purposeful. I said, go over to CU, knock on the door of a biology professor, and ask him if there's any purpose in this process. And you think that, there's something guiding it, and you'll get a little pat on the head as, no, you don't understand. That's the whole point. This thing runs on its own. It's purely materials. So, theistic evolution, as used by its proponents, who are brothers in Christ, is simply the claim that God ordained a Darwinian process of chance and selection. It's no different from the full materialist account, but it has the advantage of kind of making peace within the body. We can all go home happy and have something we want. The people who want a high view of science can have that, and the people who want to say that God did it, they go away happy. But it's not actually what's going on. Now, there's some iterations of intelligent design that I find perfectly acceptable. One that's pretty theoretical and theological is that God can see every possible world in his mind before he makes the decision to create. So essentially every possible mutation in a world that can be conceived of is known to God. And he calls forth, or he lets, if you will, a universe into existence that has all the right mutations to bring about the result. But I ask you, is that design? Yeah, it is, really it. Because suppose you're playing billiards, and you want the six ball to go in the left-hand pocket on the 527th game. And, well, by chance, you've got to play a lot of games to get that result. But for a creator over time and space, who can imagine every possible outcome of every pool game, you can say, I'm going to elect that line of gaming because that puts the six ball in the left-hand pocket on the 257th try and brings that into existence. That's a very philosophical, theological concept. Jim's had more experience than I do. But I think that's an acceptable way to do it. But it's the question, is that truly Darwinian? I don't think it is. It's a pre-selected outcome. So that was kind of a lot to drop on you just there. But I don't know where each of your individual viewpoints are. Notice that there was not really an attempt here to harmonize anything with Scripture, really, other than there's a creator. So this gives you freedom, to interpret Scriptures according to, good practices. I'll let you decide what that is. It's not my field. And also gets you, to look at the science, and I think the conclusion should be that there really is no final conflict. And I think people get into trouble sometimes when they try to impose one on another that maybe wasn't intended. So all I'm calling for here is a little bit more care in both how you interpret the scriptures and how you interpret the science. But I think certainly what we did here tonight shouldn't be any problem for someone with a high view of scripture. And it also shouldn't be a problem for anyone with a high view of science. Now, one of the problem comes in, and this is a frequent objection, is they say, yeah, but you can't actually point to the agent. When I point to an engineer that built that robot for the robot competition, it looks like you over there. And they say, you can't point to the designer that actually did it. It's called the problem of unembodied minds. They say on the earth, whenever we see a designer, we see a body that has the brain or the mind in it. But what do we really know about the mind? I just raised my hand. Who did that? Can I, all I can point to is a collection of atoms, but I have an intuition that I actually raised my hand. So, we have a deep intuition that there is a mind in us, and I don't think it's really any more problematic to believe in other minds, especially the mind of an omnipotent and necessary being. So I don't think we're doing anything unusual in inferring a mind behind bumping molecules. And I like that bumping molecules idea because I'll call them liberal theologians for lack of a better word. I don't want to cast putting them in a bad light. But one of the objections is they don't like the idea of God bumping molecules. They don't think it's elegant. But I don't know. When Jesus turned water into wine at Cana, was he bumping molecules? What was the mechanism? I don't know. But I think we have to allow that the Creator is certainly capable of doing things in the creation. So whether he selects it out of all possible worlds at the beginning, or he's actively involved in it now, I don't really need to answer that question. The point is that we can infer an agent. We know somebody did it, and I think that's the point. And for reasons like you brought up about the fine-tuning of the universe, that puts the agent outside of space and time. Because if the universe is designed, the designer is outside of physical space, physical reality, and so it's quite reasonable to believe that the designer of the universe and the designer of life could be one and the same. Anything else? Great. Well, I always hope I made sense, and this will be faith affirming for you. And when you, and I think as professional engineers, you're really in a great space to have these conversations. Because if you're on a purely academic track in graduate school, you're really limited as to what you can talk about in an academic environment. But you get out with professional engineers, not so much. This is really not a problem. And I've looked at sociological studies, I know Jim has, of who are believers in the academic world. And actually, math and the physical sciences do better than the humanities. But within the physical sciences, there tend to be a lot more believers among the ranks of engineers. And I think it's because they have a basic design intuition. So this is not an unnatural inference. And so what I hope I've accomplished here tonight is that your natural tendency to make a design inference to things in the world is not unfounded, and is in fact backed up by something rather substantial. So unless there's anything else, I think I'll conclude with that. Thank you.
I was going to see, so we usually end at 8:30, and if you need to go, that's okay. I was going to see if you wouldn't mind sharing a little bit, because you just came to Christ in 2001. You said, is that right?
Yeah, that's right.
Kind of. If you don't need to go, if you do,
I don't
that's
need
fine.
to go, no.
Just what
I
persuaded
can last
you?
longer than you can.
Yeah. What kind of persuaded you? What was it that led to you? Because it was later in life. You'd been in high school. You'd been a chemist and a high school science teacher. What led to you coming to faith in Christ?
Well, I would say I never had the really active hostility to the faith that I see today, because militant atheism just wasn't as developed when I was growing up. But I can remember that when I started high school, I had an influential friend in college who was taking philosophy courses, atheistic existentialism, all that kind of stuff. And he's feeding this to me as a high school kid who had been minimally churched. A few Bible studies, a few hymns. I know Jesus rose on Easter Sunday. But the influence, and by the way, the only subject I was good at was science. And not great, but good enough. And everything else was pretty much a bust. So it was sort of natural for me to major in it. And then I just got an impression that that robust knowledge came through the sciences, and everything else was just pretty squishy. And the whole Christian thing just seemed more like Santa Claus. And I think I personally had a pride problem. I wasn't that good as a student, but I kind of wanted to identify with smart people. I think the smart people are scientists and atheists, not that one has to be the other. And so that just sort of stuck with me. And I developed a hobby interest in mid-life, cross-country ski racing. And I was pretty good at it, to the point where I can say now I turned it into an idol. But one of the things you come up against as an aging athlete is that things start going downhill. And I was involved in business with a startup pharmaceutical company. And one of the principals of that sent me his testimony. He was a lawyer. And he looked at the historical evidence for the resurrection and predictions of the Messiah in the Old Testament and how they came true in the New. And it was in the form of a 30-page paper. And my girlfriend at the time, we were going up to ski races every weekend. I'd say, read some of that to me. I said, I never heard any of that in Sunday school. There's actually a case for the resurrection. And so I would look at it and put it away. And the more I got involved in it, I started doing internet searches. And I got into the whole, I got on the atheist websites, I got on every kind of website. And I'm doing this all by myself in my room on my computer. And finally, on some discussion board, it was on it was in finance actually, some guy asked me how I got involved with the company I did. And I said, well, the principal sent me a paper on the resurrection. He said, well, where are you on that? And I said, well, I'm still kind of kicking it around. Well, 2 days later, the Case for Christ comes in the mail. And that's kind of a classic now. It's probably close to 20 years old. But as I went through that and I did a little further work on that, I said, I'm compelled to believe this. And then it occurred, I have to reorder my life around this. Well, I've got a girlfriend in the other room, and we're living with her. And unbeknownst to me, she'd been reading Christian fiction on her own and thinking, I want what the people in these stories have. Well, about that time, someone invited me to church. I went 3 times. I asked her to go. She was raised Catholic. She said, this isn't going to be a regular thing, is it? And so I grabbed her one time, and she says, I need to believe this. So we went up to the pastor and said, I think we'd like to join, and I guess we need to be married. He says, no, you don't understand. I'll marry you, then you can join. I said, oh, is that how it works? So he made a fast trip up, and we had ordered a pizza and made a profession to each other for a Lord, and made a profession of faith in front of the church. But Sunday, 2 days later. So that's it. We're happily married. She's strong in the faith. I don't want to embarrass anybody. There's Molly here tonight. You're Molly. You know who she is. I probably told you more than you ought to know. Yeah, I'm telling stories out of school. And life in Christ has been great. But a little more background on that, and I'll talk about my book for a second because it ties in. One of the things as an aging athlete, you're slowing down, you get awareness of your own mortality. And how many have heard of Pascal's wager? A bet on God is a good bet. And I didn't know formally what Pascal's wager said, but the concept was in my head. I'm getting older. I'm not going to live forever. And what happens at the end? And I would say that's what motivated me, a sense of my own mortality, to start looking into this. Because I thought, I'm going to be dead for a lot longer than I'm going to be alive. I want to get dead right. And so it was 9 years ago that I was diagnosed with heart failure from probably too much high-end endurance sports. And 6 months after that, I had a cardiac arrest. I survived a 40-minute resuscitation. And if I didn't make sense tonight, I'll say that I had lost a few brain cells and that. But no, truly, thanks be to God. It's a wonder I can think at all. And I had some real problems for a couple of years, and things were kind of dicey. And one of my friends that I was doing this adult ed with, he said, Paul, he says, you look terrible, like you're going to die. You have some good material. Why don't you try putting it on paper in case something happens? And I went, okay. So I started writing with some of this and sent it to him. And he said, you really are a terrible writer. And well, thanks. He said, but I don't want to lose this stuff. I'll work with you. So he'd written a book on computer science, a big fat thing, and he kept sending it back to me. And it doesn't make sense. You need to complete the thought, complete the sentence. Finally, after 4 years of back and forth iterations, he said, I think you got something. And this is the product. I have about half a dozen of them here tonight. I'll either take a minimum contribution or give them away. I don't have a sales tax ID, so I technically can't sell them. And you're probably too young to remember this title, You Bet Your Life. It's the title of the Groucho Marx program. But this is what I feel is the embodiment of Pascal's wager. We're all betting our lives. And the dice is symbolic of the wager. Because Pascal, besides being known for a computer program, developed gambling theory. He was into gambling at the casinos in Paris. And it was a pretty decadent time. And one night Pascal was crossing the Seine River and he was going home after a night at the tables. And God of Abraham, Isaac, and Jacob appeared to him in a vision. And so he had a significant conversion experience. And when he was back at the tables, he wanted to convince his fellow Parisian noblemen not to be reckless with their souls. So that's really the theme of the book. And so in it, I've laid out a line of Christian evidences, but the setup is, don't be reckless with your soul. And so I've got a cosmological argument, a design argument like you asked about in the cosmos, a design from nature where I've got the Journal of Molecular Biology paper in here. And so that lays down the basis for thinking that theism is reasonable. And then I go on and develop the specific material about Jesus. And I trace what I call Jesus studies for the last 300 years and how we got to the very skeptical position that many people hold today about the life of Christ and where essentially those mistakes are. And I cover the argument about miracles because some of you probably know the philosopher David Hume, who supposedly did a number on miracles among other things. And C.S. Lewis, among others, have done a very nice rebuttal to that. And I reproduced that in here. And somebody I gave that up to knocking on doors, and he was drunk and wanted to argue with me. And 3 weeks later, he called me out and he said, I can actually believe this stuff. You made a case for miracles. Well, I didn't. I just blocked one of C.S. Lewis. So there's that kind of material in there. And I wrote this as kind of a last chance for my own generation. You know, I've got a bunch of friends getting older than I was. And statistically, it's less and less likely you're going to come to faith the older you get. I mean, I think you harden your heart, God hardens your heart, just as a Pharaoh. I don't know exactly how that works, but it gets tougher. So this was sort of an attempt to break through. It almost started out as a series of epistles to my friends and family, but the wager is illustrated with the dice, and you probably can't see the detail, but I've got different worldviews represented on the front. I've got a cross on one for theism, Christian theism. I've got an atom on another face for scientific materialism. I've got a yin and yang symbol for Eastern pantheism. That includes a lot of stuff, atheism, etc. And I got a question mark for skepticism, which is probably the spirit of the age. Everybody's skeptical of everything, especially if guys making arguments. And so it's kind of all there. There are lots of great apologetics books out there. Probably the one I point to, William William Craig, Reasonable Faith. It's really got everything. It's at an extremely high level. I mean, you can't understand it, but you know, this guy doesn't make mistakes. He debates non-Christians all over the world, the best philosophers, the best scientists. And so, you know, you could get his book for $15, but I wanted to hand these things out and make an impact. And I can crank this out for $3.75. If I want to buy people Bill Craig's book, it would cost me $15 to pass out. So some of this was a self-published, you know, that I can push out there and buy them. So that was one of the reasons why I wanted to do this. So, you know, it's an evangelistic outreach. It's not meant to be an academic work, but kind of the things we did here tonight, you know, they're in there. The subtitle is a toolbox for making one's ultimate decision. So if somebody has a real intellectual objection about something, you can, you know, there's a short treatment here, not exhaustive. But I do the problem of evil, the hiddenness of God, why bad things happen to good people, comes under the problem of evil. The Bible, hard to believe for modern people. You know, how can we believe in other animals getting in the market? And I kind of simplify that. I said, this is redemptive history. And I kind of cut through all of that by pointing to the phenomena of predictive prophecy. That you can look at passages like Isaiah 53, the suffering servant. He was pierced for our transgressions. You know, how did the Old Testament prophet know in advance what's arguably a picture of the cross? And I've proven that with people that are not schooled in church or schooled in the Bible. I said, read this, tell me what you think it's about. Kind of sounds like Easter. Bingo. And he said, how did Isaiah know that? There must be somebody above time and space that knows the beginning from the end, that's standing behind this book. So, you know, I'm not making any hard argument from inerrancy or any of those things. It's just that God has a superintendence over his word. And I'm not trying to put a finer point over that for the purposes of drawing people in. You get into the details later. Are there any errors? Are there any contradictions? But it's clear that God has superintended his word, you know, by the phenomena of predictive prophecy and other things. So, you know, it's all there. I didn't intend to turn this into a sales job tonight, but I have some business cards. This is also on the internet, so you can look it up online. There are about a dozen reviews there. One from Dr. Brodice from Denver Seminary. He's a very active apologist, not just in this local area, but nationally. And I've been at a conference with him where he's got his 800-page book for $30, and I'd say, well, you can save yourself $25 and get mine. By the pound, this is actually cheaper. But the world of Christian scholarship is enormous. I've just taken a little snippet of it here that you can use as sort of a handbook of arguments. But there's also a flow to it, reminding people that while you're arguing about things, it's really souls are at stake, in particular your soul. So don't be reckless with it. Because so many times discussions about this stuff turn into arguments. And I think we're more, sometimes we have to do that. There may be a real intellectual objection we have to answer. But we want to win people. And I think one way you can win them is say, I care for your soul, I care what happens to you. Maybe it's like read the New Testament. See if you like this guy Jesus. Would you like to spend eternity with him? Here's a way you can do it. And at the end of it, I answer the question, what must I do to be saved? And it's essentially those, verses that Billy Graham uses all the time. So, that's in there. But I also tell people that just as I struggled for 18 months looking at all that stuff on the internet, is it true, is it not? Only when you come to the point where you can sort of hold both sides of the argument in the air at the same time, I know what these guys are doing, and I know what these guys are doing, and I think these guys are right. And it may not be exhaustive, but at that point, you own the argument, and you own your own faith. And so I tell other people, if you like eternal life, if Jesus is an attractive person, someone you want to spend eternity with, then maybe this is worth your time to look into it. I can't argue you into the faith. Here's something you can work with. I'm happy to discuss it with you. It's a tool. I can point you to other tools. But, and kind of leave them with the question, if Christianity were true, would you like it? Would you like to be a Christian if it were true? And that question kind of exposes the heart. And a lot of people, depending on the stage of life they're in and where the Holy Spirit is, it may not be the time. But at least you've planted a seed, and that's what we're called to do, to be sowers. And so it's a multi-step process, and if you can just be a sower that plants a seed, maybe the next person that has a conversation with them, can move it a step along and by the power of the Spirit. So, Trent, that was a long-winded.
That was great. That was great. Well, thank you for coming.
So, I've got 1 or 2 books back there, and I'll have